Okay, let's give you guys an integration problem. So here you've got y equals cos squared, which is this red line here, and y equals 1, which is this horizontal line. The question is, which area is bigger, this area or this area A2? A2 is a combination of the two from 0 to pi. Well, work out the two areas. Okay, so press pause and have a go. Okay, so to do this we need to set up two integrals. A1 equals something something dx, and A2 is the integral from 0 to pi, so this is from 0 to pi, and then of something dx. So for A1, which is this area here, you need to move along like this. Imagine you're moving along in the x direction, that's why it's dx. Let's say currently x is here. You need to somehow work out this height, because you're summing up all the heights. You're summing up all the heights. Well, how do you obtain this height here? Well, to obtain that height, you would need to jump to y equals 1. You would need to jump to y equals 1, and then you take away this height here. Well, that height there is cos squared. Take away cos squared x dx. So look, hang on, let me illustrate it. So you're moving along, hang on. So remember, we're trying to work out this area here. So you're moving along like this. Let's say currently x is here. To obtain this height, you would need to jump to the y graph, and then you take away the cos squared graph. That will then give you this height in between the two. So this thing here represents all the heights in between the two. You're summing up all the heights from 0 all the way to pi. From 0 all the way to pi. So so A1 is given by this. So now let's look at A2. Hang on, let me clean this up. So A2 would be you summing up all the heights here. So you're summing up all these heights for A2. You're summing up all the heights for A2. You're summing up all the heights. You're summing up all the heights. You're summing up all the heights. Well, the height is given by cos squared of x, because look, you jump to the red height, that would represent the height. You jump to the line, that would represent the height. You jump to the line, that would represent your desired height. So so this thing here is really all the heights in between the x-axis and the red graph. So A2 is actually given by this. So far A1 is given by this, A2 is given by this. And remember, to integrate sine squared or cos squared, you have to use, well, to integrate sine squared you have to use this, to integrate cos squared you have to use this. We've already seen this, so I'm expecting you to know this by now. In our case, we need to use cos squared, so we've got to put this into the cos squared, and we've got to put this into the cos squared. So A2 would then become this. For A1, you've got your 1 here, and then you take away this thing here. So A2 is given by this, A1 is given by this. So let's look at A2 because it's easier. Hang on. So for A2, to integrate A2, factor out your half here. So you've got a half here as well. So factor out the half, that will then give you this. And then to integrate it, you simply integrate this, and then integrate, oops, hang on, this should be a 2x. So hang on, let me fix this. This should be, hang on, this should be a 2x. 2, hang on, 2x. Okay, so hang on. So to integrate, bear with me, to integrate this, it would just be x. To integrate this, it would be a half sine 2x. Because if you differentiate this, it will give you this. Well, anyway, that will then take us to here. and then now put this into here. That will then give you pi. Put this into here. That will then give you a half sine 2 pi, because when you put pi into here, it will be 2 pi. And then you take away, put 0 into here, which would be 0. Put 0 into here. Sine of 0 would be 0. So you can ignore the 0 here. So it will then take you to here. And then now it's well, this thing here, this block here will be 0, because sine of 2 pi, remember, sine graph looks like this. 2 pi is right here. Sine of 2 pi is 0. 0 times a half will be 0. So overall, this will be pi over 2. So A2 is pi over 2. Now let's look at A1. A1 is given by this. So now we've got to, let's break this up. Break this up as a half. So that's minus a half. And then minus a positive. That would then give you a half, this thing here. So think about it. If you break this up into one fraction and another fraction, it will then give you this thing here. Think about it. And then now single number, merge them together. 1 take away a half, that would be a half. This thing here stays intact. And then half is in common, half is in common. Let's factor out the half. So that will then give us 1. Well, looking at this, it's a half and then 1 minus cos 2x. Like so, look, this times this will then give you this. This times this will then give you this. Well, and then this half you factor it out. So that will then take you to here. And then now let me think. So now we are currently here. So now it's just a matter of integrating this thing here. So integrating this will then give you x, and then integrate this, it will then give you this thing here. So now put pi into here, that would then be pi. Put pi into here, that will then give you this thing here, and then take away, put 0 into here, which will be 0. Put 0 into here. 2 times 0 would be 0. Sine of 0 would be 0. The whole 0 times a half will be 0. So that will then take us to here. And then sine of 2 pi is 0. So this would be 0. So you're left with a half pi. So A1 equals pi over 2. A2 is also pi over 2. So what that means is, what that means is, going back to our original graph, this area here is pi over 2, and this area here is also pi over 2. And if you think about it, when you get the height, which is 1, times the width, which is pi, it gives you pi. So this is half pi, half pi. So in fact, the two areas are the same. Okay.